Prices slashed in half. US giants go bankrupt, international foundries lose money upon taking orders, China's mature chips are reshaping the life and death stakes of the global semiconductor industry. On November 28, 2025, Nikkei Asia exclusively cited Ye Guoguang, general manager of Taiwan's Qinghui Semiconductor, a veteran with 30 years of experience witnessing the rise and fall of the chip industry across the Taiwan Strait, referencing his explosive remarks on the program *Global Argument Star. He revealed a silent storm that is rewriting the global industrial order. Mainland China is frantically impacting the market for mainstream mature process chips, 40 nanometers to 90 nanometers, with an aggressive cabbage price, rock-bottom pricing strategy. This has not only slashed global prices for similar products in half but has also forced most international foundries, with the exception of TSMC, into a desperate existential crisis where taking orders means losing money, and stopping production means elimination. Who would have thought that mature chips, once unanimously mocked by Western academia and industry as a technological depression and a sunset sector, would become China's breakthrough weapon to bypass technological blockades and reshape the global semiconductor landscape? Those US chip giants that once monopolized the industry's discourse are now being dragged into the quagmire of bankruptcy by the very old technologies they sneered at. This scene has completely shattered the industrial cognition the West has held for decades. It is akin to a top-tier Michelin 3-star restaurant being forced out of business by a mass-market chain restaurant. It's not that the top chef's skills are lacking, but that the chain restaurant has mastered the entire chain, from growing ingredients on its own farms and standardized processing in central kitchens to owning its logistics distribution, thereby suppressing the cost of every dish to the absolute limit, creating a price-performance gap that is impossible to bridge. Even more subversive to conventional wisdom is that China did not stubbornly bang its head against the wall of Western-blocked EUV lithography machines. Instead, relying on the scale effect of massive wafer fabs and a complete local ecosystem, it has achieved a reverse overtaking of European and American enterprises, rendering the Western blockade logic of locking down China's chips by choking equipment supply completely ineffective. Next, we will dismantle the underlying logic of this industrial shuffle to see how China is using old technology to reconstruct global technological competition rules, and what this means for the European and American industrial landscape. In the solidified cognition of the West, the winning move in the chip industry always lies in advanced processes, with EUV lithography machines being the insurmountable chasm. In 2022, the United States introduced the $280 billion CHIPS Act, strictly choking off exports of advanced technology below 7 nanometers, certain that China would be trapped in a technological bottleneck. Yet, the reality is that China turned around to deeply cultivate mature processes from 40 nanometers to 90 nanometers. Relying on the massive scale of 100 wafer fabs, China captured 29% of the global 12-inch mature chip market share in 2023, which is expected to soar to 47% by 2027. By 2029, it is poised to become the world's largest manufacturing base for mature chips. In contrast, the US company Wolfspeed, once the leader in silicon carbide (SiC) wafers, initiated bankruptcy protection proceedings in May 2025 with debts as high as $6.5 billion. This was because Chinese manufacturers crushed the price of 6-inch products from $1,500 to $500, causing Wolfspeed's market share to plummet from 60% to 33.7%. This is not a technological regression, but a failure of the Western cognitive model that relies on advantages in a single link. At a time when 83% of global chip demand is concentrated in mature processes, China has grasped the essence of the industry rather than blindly chasing technological gimmicks. This pragmatic route has struck precisely at the soft underbelly of the Western high-cost model. Commentary and analysis. The West's obsession with advanced processes is essentially a path dependence formed by the long-term dominance of Moore's law, and an inertial mindset attempting to maintain industrial discourse power through single-point technological monopolies. This has caused them to completely overlook the core reality that 83% of global chip demand is concentrated in mature processes. China's full-chain layout has shattered the myth of process supremacy. It is not a simple piling up of production capacity, but a closed-loop construction from equipment and materials to end-user demand. This proves that the ultimate core of industrial competition is ecosystem resilience, not technological leadership in a single link. Wolfspeed's bankruptcy is by no means accidental. It is the inevitable result of the West detaching from market demand and indulging in technological arrogance, and a landmark event in the global chip industry's shift from a single-point technology race to a full-chain ecosystem competition. This shift in landscape is forcing Europe and the US to re-examine their technology strategies and break the drawbacks of fragmented layouts, otherwise, they will completely lose the initiative in the new round of industrial reconstruction. Behind the cost advantage lies China's slow but complete industrial chain construction logic, which stands in sharp contrast to the fragmented layout of Europe and the United States. Operating costs for Chinese wafer fabs are 11% lower than their Taiwanese counterparts, and the cost advantage in silicon carbide wafers is even more significant. Nora Technology Group's crystal growth furnaces sell for only $2 million, half the price of imported equipment. Coupled with industrial electricity prices as low as 8 cents per kilowatt-hour and local government subsidies of 150 million renminbi per 10,000 units of capacity, a cost barrier that is difficult to replicate has been formed. European manufacturers, meanwhile, are trapped in a passive position. Germany's X-Fab, facing Chinese quotes below cost, was forced to close its 6-inch production line in 2023. Transitioning to 8-inch processes took 3 years, resulting in severe revenue fluctuations. American companies are under similar pressure. Applied Materials has seen sales continuously decline due to the increase in China's equipment self-sufficiency rate, and Lam Research was forced to cut prices by 30% to grab market share but still struggled to reverse the decline. More critically, China possesses 80% of the global PC capacity and 60% of the new energy vehicle capacity. This massive domestic demand provides a stable foundation for chips, an advantage that the single markets of Europe and the US cannot match. Commentary and analysis. China's cost advantage is definitely not just about simple subsidies, but the inevitable result of full industrial chain synergy and scale effects. Europe and the US rely overly on advantages in single links and lack complete ecosystem support, naturally making them vulnerable in a price war. This gap is essentially a difference in industrial strategy. China's full-chain autonomy route has stronger risk resistance, providing a diversified paradigm for global industrial development, and also forcing Europe and the US to re-examine the importance of supply chain integrity. That strategic retreat of global chip giants further highlights the foresight of China's mature process layout. In early 2026, TSMC, Intel, and Samsung collectively shrank their mature process capacity. TSMC slowed down the movement of advanced equipment into its Nanjing factory, Intel focused on the 18A process, Samsung reduced low-end memory chip production lines to sprint fully towards the high-end track, leaving a market void of nearly 300 billion renminbi. Chinese enterprises precisely took over this space. SMIC spent 40.6 billion renminbi to acquire the remaining equity of SMIC Jingcheng, SMIC Beijing, and Huahong Group integrated Huali microelectronics capacity. In 2024, China's mature chip capacity accounted for 28% of the global total, expected to rise to 39% in 2 years. Conversely, in the US, global foundries, supported by CHIPS Act subsidies, failed to shake China's scale advantage due to missing the early opportunity in the mature market, seeing its market share actually decline in 2025 despite government funding. Commentary and analysis. The strategic contraction of the giant seems rational but actually exposes the fragility of the European and American industrial structures, an excessive pursuit of high-profit, high-end markets while ignoring the foundational support role of mature processes. China's active takeover of the market void has not only expanded its share but also perfected its industrial ecosystem. This misplaced competition suggests to the world that technological development should not fall into high-end worship. Only by balancing layouts in both high-end and mature fields can a more robust industrial system be built. The core of this industrial shuffle is a rethinking of the path of human technological development. Moore's law is approaching physical limits, and the cost of advanced processes is rising exponentially. China's breakthrough in mature processes provides a new direction for the global chip industry. The US tried to maintain a monopoly through technological blockades, but instead forced China to build an autonomous ecosystem. Europe stuck to high-end manufacturing but lost its voice in foundational fields. Meanwhile, China, by accumulating funds and technology through mature processes, is gradually breaking through to 28 nanometers and more advanced nodes. Amex etching machines have entered Samsung's supply chain with a 25% share, and JCET's advanced packaging technology has gained NVIDIA's reliance. This gradual breakthrough shatters the Western binary cognition of either leading or lagging. Commentary and analysis. China's chip breakthrough is essentially a reconstruction of traditional technological competition logic. It proves that technological development is not a zero-sum game, but that mutual benefit can be achieved through differentiated paths. The falling price of mature processes will lower the threshold for industries like new energy vehicles and the Internet of Things, IoT, benefiting consumers globally. If the West continues to cling to a blockade mindset, it will only miss out on opportunities for industrial transformation. Only through open cooperation can they conform to the common trends of global technological development. The reconstruction of the global semiconductor landscape has long ceased to be a victory or defeat of a single technology, but a comprehensive contest of ecosystem, scale, and strategy. China's breakthrough in the field of mature processes has not only rewritten industrial rules but also revealed a truth: the ultimate goal of technological development is to serve all of humanity, not to monopolize technological dividends. This transformation has just begun. How will China continue to break through to advanced processes? And how will European and American companies adjust their strategies to respond?